Testing a claim about a population proportion, the normal approximation method. The objective is to conduct a formal hypothesis test of a claim about a population proportion P. The notation: N is the sample size or number of trials. P is the population proportion. P is the value used in the statement of the null hypothesis. P hat is the point estimate, which is x over n, which is the sample proportion. Q is the complement of the population proportion, which is 1 minus p. And the requirements. Number 1, that the sample observations are a simple random sample. Number 2, the conditions for a binomial distribution are satisfied. There is a fixed number of trials. The trials are independent. Each trial has 2 categories of success and failure. The probability of success remains the same in all trials. And number 3, the conditions n times p is greater than or equal to 5 and n times q is greater than or equal to 5 are both satisfied. So the binomial distribution of sample proportions can be approximated by a normal distribution with the population mean equal to n times p, and the population standard deviation is the square root of n times p times q, as described in section 6.6. Note that the population proportion p used here is the assumed proportion used in the claim, not the sample proportion p hat. So number 1, first thing you want to do is state the claim and the opposite of the claim. Number 2, identify the null and the alternative hypotheses. The null hypothesis is the statement is assumed true until evidence indicates otherwise. The alternative hypothesis is that the claim to be tested. 3 ways to structure a hypothesis test for a population proportion. You have a two-tailed, a left-tailed, and a right-tailed. For each of the null hypotheses, the population proportion is going to equal the proportion value. The alternative for the two-tailed would be p does not equal the proportion value. For the left-tailed, p is less than a proportion value, and for the right-tailed, p is greater than the proportion value. Now, the alternative hypothesis is the one not containing equality. So the alternative hypothesis uses the following 3 symbols: less than, or greater than, or not equals to. The null hypothesis is a symbolic expression that the parameter equals the fixed value being considered. Number 3, you're going to use the alternative hypothesis to determine whether it is a left, right, or two-tailed distribution. Number 4, you're going to select the significance level, alpha. Based on the seriousness of a type 1 error, you make alpha small if the consequences of rejecting a true null hypothesis are severe. And the values of 0.05 and 0.01 are very common. Number 5, the test statistic for testing a claim about a proportion. So the test statistic that you use about a proportion is z, which is equal to the point estimate minus the population proportion divided by the square root of the population proportion times q, which is the complement of the population proportion, divided by n, which is the sample size. And number 6, you're going to find the corresponding p-value or critical value and then draw your curve and label. So when using the p-value method, p-values are provided by technology or using the standard normal distribution, which is table A2. The critical value method, critical values are provided by technology or using the standard normal distribution, which is table A2. And number 7, you're going to make a decision. So for the p-value method, you reject the null if the p-value is less than or equal to alpha. You fail to reject the null if p-value is greater than alpha, which are the significance level. For the critical value method, you reject the null if the test statistic is in the critical region. You fail to reject the null if the test statistic is not in the critical region. And then you're going to state the conclusion. So, the original claim does not include equality and you reject the null, then you would say there is sufficient evidence to support the claim that you would write the original claim. If the original claim does not include equality and you fail to reject the null hypothesis, then you would state that there is not sufficient evidence to support the claim that, and then rewrite the original claim. If the original claim includes the equality and you reject the null, then you would say there is sufficient evidence to warrant rejection, the claim that, writing the original claim. And then if the original claim includes equality and you fail to reject the null, then you would say there is not sufficient evidence to warrant rejection, the claim that of the original claim.